Section 3.3 is System of Inequalities. I can solve systems of linear inequalities. Big ideas for this section. A system of inequalities can be solved in more than one way. Graphing is usually the most appropriate method. The solution is the set of all points that are solutions of each inequality in the system. Solving a system by graphing here. We can also use tables. I'm not going to spend a ton of time on that. There is an example in the book, but that's a lot more labor intensive and time consuming. So we're going to do it by graphing and then come up with our values from there. So we want to know, what is the solution of the system of inequalities? Similarly to how we graphed systems of equations in order to find our solution, we're going to graph each inequality as it's written. So 2x minus y is greater than or equal to -3. First thing I'm going to do is solve for y. I add or subtract first to get rid of anything that doesn't have a y in it. Then I get my y by itself by dividing by -1 to both sides entirely, or every term. Keep in mind, when we multiply or divide by a negative number, we have to flip our inequality. So here I'm going to start at my intercept. And use my slope of 2 to go up 2 over 1, up 2 over 1, or down 2 back 1. Then I connect my dots. Here it's going to be a solid line because my inequality has an equal to there. Okay. Now I know it's an inequality, but I'm going to come back to that step here in just a minute. My second equation is already in slope-intercept form. So I'm going to start at my intercept on my y-axis and use my slope to go down 1 over 2. Or I can go up 1 back 2. Here again, it's equal to, so it's going to be a solid line. And there we go. Now, we have these inequalities and we need to graph those. But keep in mind, when we have a system, whatever our solution is has to work for all of our equations or inequalities. So here, with my yellow line, I want my y values to be less than, or my shading to be less than. So I'm going to go below my line. Less than means lower. With my like pinky purple line here, again, I want it to be less than, which means lower. Now, as far as our final solutions go, we only shade the part where it overlaps. So the part that works for both inequalities is this section of my coordinate plane here. That's going to be my solution. Okay, on the left side here, it only worked for one. On the right side, it only worked for one equation, and on the top, it didn't work for either. Another way you can do this, if you really want to, guys, is you can shade in the whole sides and then see where they overlap. So my yellow line we wanted below. My pinky purple line we wanted below. And if I look, this section here is where they overlap. So that is my solution. And I just get rid of everything else. So whether you use the arrows or you shade in completely, it doesn't matter. Just keep in mind, we're just looking for where they overlap, what works for both. Just like our intersection of our equations, okay, was just a point, here our intersection of our inequalities is that entire region. Now, feel free to pause here and give this a try if you'd like. We want to know, what is the solution of the system of inequalities? So I'm going to graph each line. My top line is in standard form, so if I want to, I can use intercepts here. To find my x, I plug a 0 in for y. So my x-intercept is going to be at 4. My y-intercept, I'm going to plug a 0 in for x. And solve. So my y-intercept is going to be at 2. You can also solve for y there, and we'll get y less than or equal to -1/2 x plus 2, and that would have worked as well. I'm just going to continue this pattern a little bit here, so that when I draw on my lines, I have more points. Because it's equal to, this is going to be a solid line. And there we go. My second equation here, or inequality, is already solved for y. It's already in slope-intercept form. So I'm going to start at -1. And my slope is -1/1. So down 1 over 1. Or we can go up 1, back 1. And draw in my line. Now, in order to find our solution, we need our shading here. So, from my purpley pink line here, I want them to be less than. I want y to be less than 2, x to be less than 4. So I'm going to go in this direction. For my yellow line, I want it to be greater. I'm going to go in this direction and that direction. And it's hard to see up top where they meet, but the purple's going out and the yellow's going in. Not what we need there. So where they overlap is just this part in between here. And I can get rid of the rest of this here. And that is our solution. We can model a real situation with a system of linear inequalities. Oftentimes, these solutions are whole numbers, so only certain points in the region of overlap will solve the problem, and that's the case here in example 3. A pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. We want at least 5 toppings on our pizza, and we have $10 to spend on toppings. How many of each type of topping can we get on our pizza? So they're going to count it as a whole topping here, guys, anytime it's something different. So let's say they only put 1 Canadian bacon on our pizza. That's still a new topping. So we can't have like 3.2 or -4.1 amount of toppings. They have to be 0 or positive, and they have to be whole numbers. Okay, we're not going to have decimals or fractions here. So we have 2 situations that we're talking about. We want at least 5 toppings, and we have $10 to spend. So one of them deals with quantity, one of them deals with cost. So veggies and meat are our 2 variables. Our quantity is veggies plus meat, the amount of veggie toppings we have plus meat toppings. And we want at least 5 toppings. So we could have exactly 5, and then we have to check, is it more or less? Well, at least 5 could be 7, but it can't be 3, for example. 3 is not at least 5, 7 is at least 5. So we want numbers that are greater than or equal to 5. We also have an equation here for cost. Okay, we have $10 to spend on toppings. So the amount of money that we spend on veggie toppings is $1 per topping. So $1 times the number of veggie toppings. And the amount of money that we spend on meat toppings is $2 per topping. So 2 times the number of meat toppings. And we have $10. So we could spend our entire $10, but we can't spend 12. We could just spend 7 if we wanted. So here it's got to be less than or equal to. So if you're not sure which way your inequalities go, try some test points. I used 7 and 12 and 10 and 3, things like that. So try some values and see what would work and what wouldn't, and then plug in the appropriate inequality. So here, I have 2 equations, 2 variables I can go ahead and solve. It doesn't matter which variable we put on which part of our graph because neither one really depends on the other here. So just make sure you label them. Now, if I, for my first equation, just want veggies, don't want any meat, I could have 5 as my intercept for veggies. Okay, if all I got were veggies, I could have at least 5. Now let's say all I got was meat and I got no veggies. I could have at least 5 meat. Same thing for our second equation here. If all I wanted was veggie toppings, no meat toppings, the amount of veggies I would get would be less than or equal to 10. And if all I wanted was meat topping but no veggies, and I solve for m here, the amount of meats would be less than or equal to 5. Okay, so these are my intercepts. And I can connect these with straight lines because we said on both of them that they are equal to. So solid lines here, from 10 to 5 and from 5 to 5. Now we have to figure out which way we're going to shade. We want our toppings, which is this line, to be greater than or equal to 5 in number. So we want to go this direction. We also want the money we spend, which is this equation, that line, inequality, to be less than or equal to 10. Less than goes this way. So where they overlap here is everything in the middle. Keep in mind, though, that we can't have 3.2 meats. Okay, so our solutions are just going to be our whole number values here. So just on the corners where we have whole number, I'm not hitting the corners very well, but just the corners here where we have answers. There we go. So all those points that I have here are our options. We could have 3 meats and 3 veggies. We could have 6 meats and 6 veggies and 1 meat. Any of those options satisfy both of our inequalities. Example 4 here, we have another system of inequalities, and we're going to do this very similarly to how we did the last couple. The only difference here is instead of having just a linear system, we have an absolute value, which means this graph right here is going to be V-shaped. Anytime we have just one variable, our equation or inequality is one-dimensional. So here it's y, we have an intercept at 3, and it's going to be a horizontal line through 3. And it's a line that's filled in because of the equal to here. We want it to be less than that line, so somewhere below. My second equation is a V shape because of my absolute value. My translations here are right 1. So instead of being at 0, 0, I'm going to start at 1. And then I'm going to go up with a slope of 1 because I have no stretch or compression. And a slope of negative 1 in the other direction. Okay, same idea, just reflected. Now, this is also equal to, so I can connect with a line. And for my absolute value, I want below it as well. So somewhere here, here. The part that overlaps and works for both is everything below that absolute value and below my y line. So here is my solution. The part above, okay, everything up here, doesn't work for both equations. And remember, it has to work for both. So this right here, my shading that works for both, is my solution. We wanted below our absolute value and below our y line. Now feel free to pause here and give this a try. I've zoomed my graph in because we're going to have just a small area to view here. So my intercept is at 1. Slope is negative 1 over 3, down 1 over 3, or up 1, back 3. Here it's going to be a dotted line because it doesn't have the little equal to in it. So it's going to be something kind of like this. You should use a straight edge to make sure that you're getting yours where it needs to go, but a rough sketch like that. My second one is a V-shaped graph. Absolute value, I go right 1 and stretch by 2. So I'm going to start at 1. And my slope is 2. I go up 2 over 1 because of that stretch by 2. And again, we're going to graph these absolute values the same way we did last chapter, the same way we have been doing, just like we did with our lines. This one is also dotted. And mine aren't very straight here, but you get the idea. We want to go above our absolute value and below our second line, so our answer is just right in this part. And that's all I have for section 3.3.